Next, let's generate the genotype likelihood. So I have already posted Hong's paper published in Bioinformatics on the statistical framework on how to calculate the genotype likelihood. So you can look at the paper for the detailed equations, how to calculate the genotype likelihood. So we use SAM2's MPLAB with the -v option to calculate the genotype likelihoods. You can also use BCF2 to do this. So BCF2, if you use BCF2 for both genotype likelihood calculation, the PLAB function, and the call function, you can avoid in case there is a mismatch in the versions between SAM2 and BCF2. That will cause some error in your variant calling. So okay, now we already generate the VCF file. Let's take a look. Genotype VCF. There are two parts in this VCF file. It's similar as the SAM file. The first part is the header part, start with 2 punch sign, and the second part is the read part or the variant part. Let's first look at the header part. The header section contains the specifications on various terms that used throughout the file. For example, if we see a pass in the filter field column, then that means all filters passed. And if we see a DP in the info column, it means the raw read depth, how many reads in that position. If we see a VDB, it means the variant distance bias for filtering splice site artifacts in RNA-seq data. And if we see a PL, it means the calculated genotype likelihood in the Phred scale. It's like similar to the Phred scaled base calling quality score or the mapping score calculated in Phred scale. And the next is the read section. For the read section, I would like to see each read per line. So I will use the less dash capital S. So each read will show in one line. There is no clip. And now we can see it's clearly that the first is the chromosome on which the variant occur. And here, since the Ebola virus just one chromosome, so it's all just one contig. And then the position and the ID, that is usually an identifier for the variant, and typically is a dbSNP database if that is known, and the reference base, alternative base if there's any, and the QUAL is a probability that the reference and alternative variants exist at this site. Filter has the name of the filter that the variant fails to pass. Here in this level, we haven't applied any filter yet. And info contains the site-specific annotations. And the format is sample level annotation. We will explain more in details for the VCF format later. Before doing that, let's finish up the call, BCF2 calls. you can copy paste the command. And this, after calculating the genotype likelihood, we can do the variant call by BCF's to call command and indicating the ploidy for our species. And then we can look at the result file. This time is BCF2. This VCF file contains only the variant size, so it's much smaller than the first one. As you can see, it starts from the position 127. And if we look at the size of these two files, this one only 80K, but the original one is 3 megabytes. And we can count how many lines. So it's 590 lines. So it's about 500 variants in this variant calling process. And a typical VCF file from a human whole exon sequencing experiment may contain 80,000 rows, and a typical human whole genome sequencing experiment can produce a VCF file with 4 million rows. Next, I will show some simple examples of the sample column in the VCF file. For example, if we see in the format, it's GT colon PL, then that means in sample 1, the number before the column is the GT, and the number after the column corresponding to PL. And what is GT and the PL mean? We need to go back to the header of this file and look at their definition. GT is the type is a string character, and the description is a genotype. And the PL, the data type is integer number, and is the Fred scaled genotype likelihoods. So next, the reference column is represent the reference allele at the position. The alternate column represent all variants observed at that site. It not has to be just one alternate allele. It could be multiple, even though biallele is most frequent in human genome, but we still have like 0.5% probability observing more alleles. And say a SNP at position 60, this example show a SNP at position 60, while the reference A is replaced by the alternate allele T. And if we have two possible variants, then in the reference A, and the alternate has T and C. Below is a variance representation in VCF format. For SNP, it's simple. For insertion, it's just add the inserted bases after the reference base. And the deletion, the reference is ACG and the alternate is A. And for replacement, the reference is ACG and the alternate is T, replaced both C and G. And for large structural variants, the VCF representation is like this. It just shows the ending position, and the starting position is in the position column. So next, let's talk about more in detail what is the genotype and the genotype likelihood. So even though the reference and alternate column show the change, we have to know how many copies of the DNA carry the variant. And this is encoded in the field GT. For example, in the GT field, 0 indicates the reference field, 1 indicates the first entry in the alternate field, and 2 indicates the second entry in the alternate field, and so on. For example, for diploid organism, the GT field can indicate the 2 alleles carried by the sample. 0, 0 means the sample is homozygous reference, and 0, 1 means it's heterozygous, carry 1 of each. 1, 1 means it's homozygous for the first alternate, and 2, 2 means it's homozygous for the second alternate, and 0, 2, 1, 2 are heterozygous. And the genotype likelihood are normalized probability that describe the probability each of the possible genotype occurs. The value is normalized to 0, so the most likely genotype is 0, and the rest are computed relative to that. Since it's a statistical measure, it's the chance of not observing the genotype, so the best value is 0. For example, here, this indicates that the support is highest for genotype 0, 1, that is shown as 0 in the middle, and the chance for the first genotype is Phred score 51, which means there is a chance about 1 out of 10,000 that we see this, observe this genotype. And the last genotype likelihood, 48, the Phred score 48 means there is a chance about also 1 over 10 to the order of 5, the chance we see that we observe that genotype.